In this notebook, we'll be using a library developed by Hugging Face called Parameter Efficient Fine-Tuning, abbreviated as PEFT. This PEFT library supports multiple methods of PEFT. If you are curious what methods Hugging Face has implemented, you can check out their documentation, scroll down to the bottom left, and you'll see that they have LoRa, prompting, and also IA3 implemented. In this demo notebook, we'll be using prompt. There is also only a subset of models and tasks that are supported by this library for the time being, and if you're interested to learn more about it, definitely check out their documentation as well. So first of all, we will download PEFT and also download the classroom setup. Once this is done, we can proceed with the next cell where we are calling the auto classes to help us retrieve the relevant model and tokenizers. Some of you might have seen this auto classes before. It is a very convenient class by Hugging Face to help us to automatically retrieve the relevant models and tokenizers given the pre-trained models that we are interested in. We'll use a causal language model, or also known as autoregressive model, to generate text. And this pre-trained or foundation model that we're using is called BloomZ. If you're interested in checking out BloomZ, definitely read more about the model here. It is trained on a multilingual dataset spanning across 46 different languages and also programming languages as well. So we are going to load the tokenizer and also foundation model from BloomZ on Hugging Face. In this notebook, I want my model to be able to generate inspirational English quotes. Before doing any fine-tuning, I'm going to see how my foundation model currently performs on the input sentence that I provide without doing any fine-tuning. So that's what we will do in the following cell over here, where we provide an input of two things are infinite, and we'll ask the foundation model to generate the output text. And you will see over here that the output text is the number of people and the number. So you will see that this is not too bad of a response, but I'm curious to check after we fine-tune this foundation model based on inspirational English quote dataset, whether the model will give us more inspirational quotes. So the dataset that we'll be using is called English quotes. Let's check out what this dataset looks like. So it's a dataset that has quotes from famous people, and we are going to basically fine-tune our BloomZ model on this dataset. Hopefully by the end of the fine-tuning process, it will learn something about being inspirational or philosophical, so the outputs can also have such characteristics as well. To speed up the fine-tuning process, we'll fine-tune only on 50 examples of the inspirational quotes. So now that we have our data set and also our foundation model ready, we are now going to start with fine-tuning. We'll apply prompt tuning as our first PEFT technique. Remember that prompt tuning allows both random initialization and text initialization. In this section, we'll first use random initialization and then text initialization so that we can compare the text output differences. Without further ado, we're going to start with random initialization. And all we need to provide, as you can see over here, is the length of the soft prompt, which is denoted by the number of virtual tokens. And we're also going to specify the task type, which is causal language modeling, and specify that we want random initialization. And just like that, we're able to dramatically reduce the number of trainable parameters to less than 0.01%. And this is the beauty of PEFT. Because it's really easy to use, we can apply PEFT to our model of choice, and it will help us to reduce the number of trainable parameters. Next, we are going to use Hugging Face trainer class and also training arguments to define our fine-tuning configurations. You can see over here that our training arguments would tell Hugging Face where to save our outputs, what is the batch size, and what is the learning rate I want to call out that the learning rate that we are using over here is much higher than what we would do for a typical full fine-tuning, because we're now using only a subset of parameters to fine-tune, and that requires a higher learning rate to be more effective. And here we're going to use a somewhat small number of training epochs, and epochs just means the number of passes for the model to go through the entire fine-tuning dataset. Now that we have the training arguments ready, we can pass this into our trainer class. Trainer class is a convenient class provided by Hugging Face so that we do not need to write our custom training loop. If you are curious about it, you can also check out their documentation, their trainer class over here, and you can also choose to write your training code using native PyTorch code as well if you wish. But this is going to be easier if you don't have a lot of customizations that you need. So in our trainer class, we're going to pass in our path model, our training arguments, the fine-tuned training examples, and also how we are going to batch our data records. So data collector is a function that can help us to form batches of inputs to pass in the data, to pass into the model for training. We're also going to toggle this MLM flag to be false, where MLM stands for Masked Language Modeling. Remember that we are now using causal language modeling as our task, so we will need to turn MLM to be false. Specifically, this data collector for language modeling will also additionally pad all the input to the maximum length of a specific batch, because inputs can have variable length. And now we're going to start training. So this training process of 5 epochs might take up to 10 minutes to train. And you might also see that when you run this cell, it will trigger a whole new MLflow run. If you are not familiar with what MLflow is, you can check out the documentation that I've linked here. It is a tool that can help us to manage end-to-end machine learning lifecycle, and is open sourced. So in this case, during the training process, it will help us to track the hyperparameters, any artifacts, and also any metrics that we specify. So this is automatically triggered on Databricks. When the training is done, we can now save this model locally. We're going to specify the path of the model, and then we're going to use the trainer model to save it to this path. Of course, the next thing that we can do is to load this model from this local path and then ask the model to generate text based on our input before. So here, notice that we are loading our foundation model and where we save our path. And now we can ask Hugging Face to generate us the rest of the output based on our input. So you can see here that to this phrase, 2 things are infinite, now it generates the output of time and space. So this is maybe getting closer to being more philosophical and inspirational. And also note that if you run this on your own, you might get a different response from what I'm seeing now, or maybe even the same response as the foundation model. And that's just because we are not really fine-tuning for that long, and we're not really providing that big of a fine-tuning data example to this fine-tune model. So if you want the performance of this decoding to improve, then we should definitely fine-tune for longer or provide a bigger set of fine-tuning data. But it does seem like it is maybe getting more inspirational based on time and space response over here. And in fact, the input above, 2 things are infinite, is taken exactly from the training data set. So from the training data set, we could see that this is a quote given by Albert Einstein. He said that 2 things are infinite, the universe and human stupidity. So definitely much more philosophical. So now that we have seen how random initialization works, I want to show you how text initialization works. So the only difference with text initialization is that we simply add this additional argument of providing some starter prompt for the model to search over. So you can see that over here, I have my prompt tuning init text to be generate inspirational quotes. And I can also specify number of virtual tokens here as well. And this doesn't have to match the number of words that you provide in the text prompt over here. This just provides a starter for the model to start searching over. So it will start to learn from this, generate inspirational quotes, and then find the best embedding representation for your prompt. So the rest of the steps will be exactly the same. So we have our prompt tuning configuration set up by setting up the text prompt and also changing this from random to text. And then the rest of the configurations to the trainer class will be the same, where we pass in path model, training arguments, or training examples, and all the same data collector as well. And then continue with training or fine-tuning. Roughly 10 minutes later, we'll have this model ready, and then we can also do the same thing of using this model to generate us an output. And now let us compare the differences between random initialization versus text initialization. So you will see that now our text initialization output gives us the output of the number of people that you can count. So this is not too bad of a response either, even though this is not exactly two things. But you can see that for random initialization versus text initialization, there's really not much difference in terms of the output performance, or rather, I should say that the evaluation of how good these outputs are can be quite subjective. And of course, it is really hard to judge objectively how good the models are depending on the initialization based on just a single example. So I would definitely say that we need more examples to test on to properly evaluate whether text initialization or random initialization is better. But the takeaway here is that text initialization doesn't necessarily perform better than random initialization. And in fact, if you recall from the lecture, oftentimes random initialization can match the performance of text initialization, and there's not much performance boost in terms of using text initialization. So that is often one reason why people might opt to choose to use random initialization, because that removes the manual labor of keeping track of the starter text prompt that you provide to the model itself. Now let's look at the optional part of sharing this model to Hugging Face Hub. Say that you have a model that you are really proud of, and maybe you are really proud of the random initialization model that we just produced, and we want to share with the rest of the Hugging Face community. So we can choose to push our model to the Hugging Face Hub. All you need to do is to first create a free Hugging Face account. The sign-up process is pretty simple. You will first have to go to the Hugging Face homepage and click Sign Up on the top right corner. On the top right corner over here, once you are signed in, then you are able to see that you have a list of models or data sets that you have posted to the Hugging Face Hub. But before you can post your model to the Hugging Face Hub, you need to also first generate an access token. So you can go through step 2 and step 3 on your own. Feel free to pause this video to get the access token. The next thing that I'm going to do is to use Databricks secrets to pass in this Hugging Face token so that it knows my Hugging Face API key behind the scene. If you are not sure how to use Databricks secrets, you can visit the documentation over here. Or rather, more easily, Hugging Face also provides a helper logging method that prompts us to enter our token interactively. So when I run this cell over here, you will see that it asks me to put in my token over here, and then I can simply just copy paste the access token that I've gotten from Hugging Face, put this in, and then click Login. And then if it recognizes that my token is invalid, then it will tell me so. If not, it will say successful. And that is how you can interactively log in to Hugging Face account. So I'm going to use the Hugging Face key that I've already stored in my Databricks secret scope. And the next step will be that you need to recognize first what is your Hugging Face username. So fill in fill this in with your own Hugging Face username, and feel free to leave the rest the same. And we're now going to push this model, our path model, to Hugging Face Hub. So I'm going to rerun this cell. And then now when I visit my Hugging Face Hub again, I'm going to click on my top right button and I click on my profile. And you will see that now I have a model pushed to my own hub less than a minute ago, which is this exact model that I have pushed. I can also go to files to check the configurations and also the model object itself. So this is how someone can choose to load model from another person's Hugging Face Hub. And you might have already done this without realizing before. So say that now I've pushed my model to Hugging Face Hub, which is this one right here, and I'm going to use this model from this path to generate my inference. What I can do is simply provide the same path model ID and then provide the foundation model that I used before based on the configurations. And then I will be able to load the model and then generate output. And you will see that the response that I'm getting for this random initialization model, time and space, is the same as the first model that we saw above, because it is the same model, just that the location is different. So there you go. You have successfully applied path prompt tuning for the first time. In the lab notebook, instead of using prompt tuning, you'll be applying LoRa instead.